Hello class, welcome to lesson 11.8, which is all about rational equations. By the end of this lesson, you should be able to solve rational equations and use them to solve real-world problems. Let's start by solving these first two equations and see what we end up with. Now that we're doing equations, that means we're finally solving for the actual variable that we are dealing with. And if we look at our first example, we have 7 over y minus 3 equals 3 over y plus 1. Okay, so remember, when you have a fraction that equals a fraction, one way to solve is that you can start by multiplying the diagonals together. So if I start by multiplying my green diagonal, I end up with 7y, and then, so I multiplied 7 and y, and now I have to multiply 7 plus 1, so that's plus 7. And that ends up being equal to, I have a 3 times y, so 3y, and then a 3 times a negative 3, so a minus 9. Now all I have to do is solve for y. So we're back to equations with variables on both sides, which is something that we covered at the very beginning of the year. So I'm going to move my 3y over to the left-hand side by subtracting it, so 7y minus 3y gives me 4y equals, and then I'm going to move my positive 7 from the left-hand side of the equation over to the right-hand side. So I'm going to subtract 7 from both sides. So now I have a negative 9 minus 7. That gives me a negative 16. Now, if I want y by itself, I have to move the 4. 4 is currently multiplying y, so we need to divide. And that leaves us with y equals negative 4 as our solution. Okay, let's try it with the next one as well. If we multiply on our diagonals, 13 times 7 gives me 91, and that equals 10 times 2f, or 20f, and then 10 times 0.02, or plus 2. Now all I have to do is solve for f. F is already on, the variable's already on one side of the equation, so I'm going to subtract 2 from both sides. So I have 89 equals 20f. If I divide 89 by 20, I'm left with f equals 4.45 as my answer. Alright. Now it's your turn. Take a minute and see if you can figure out this equation. Hopefully you ended up with letter C, or negative 3, I guess, because Edpuzzle doesn't keep the order of the answers for you. So hopefully you got negative 3. Alright, let's take a look at example 2. We want to solve this equation. We have 5 over x plus 1 minus 1 over x equals 2 over x squared plus x. So I look at this problem and I see on the left-hand side I have two different denominators, and I want to find the least common denominator of x and x plus 1, which I'm pretty sure is going to be just x times x plus 1, because I don't see anything right away, and as we discussed yesterday, one way to get a common denominator is to multiply the two denominators together. So if I take everything, I'm going to move this so I can just write. If I take everything and multiply it by our least common denominator, what I do to one side of the equation, I must do to the other. So if I do x times x plus 1. Alright, that's legal, right? Because I multiplied both sides of the equation by the same thing. What you do to one side, you must do to the other. Okay, so I'm not really changing anything. And now, if I look at this, I can distribute it. So now I have x times x plus 1. Treat that like it's over 1 times my first item. And then I'd have my x times x plus 1 over 1 times 1 over x. And that equals the same thing over here. when I look at that x squared plus x on the right-hand side of the equation, I see they both have an x in common, so I want to change that. Let's change that by pulling out an x and say that's x times x plus 1. Alright. Let's go back over to the far left-hand side of this equation and let's start looking at things that can cancel on the diagonals. I see I have an x plus 1 and an x plus 1. So that means this first term just becomes 5x. And then I carry my minus, or my subtraction symbol. I see I have an x and an x. And I have x plus 1 times 1 over 1. So that just becomes minus x plus 1. And then I have, on the right-hand side of the equation, these all cancel, so then I have 2. Sorry, x plus 1. And I just have 2. If I keep solving, I now have 4x. When I combine my x's, plus 1 equals 2, or x equals 1, because I subtract. No, I don't. I made a mistake. Sorry, guys. I was right to keep the parentheses there. Now this becomes 5x minus 1 equals 2, because I have to distribute that negative sign. Alright. Now I have my 4x minus 1 equals 2, or I have 4x equals 3, because I add 1 to both sides, and now I know that x equals 3/4. Alright, sorry for the little bit of confusion there. Let's have you take a look at this next example and see if you can figure it out. Good luck. Hopefully you ended up with 8 as your answer. If not, be sure to ask either myself or a friend. Let's take a look at our third example. We want to solve the equation and state any extraneous solutions. Remember, an extraneous solution is one that does not exist. Okay? It's a solution that does not exist. It's a number that works, but in some way it doesn't work. I know it's confusing, but we'll talk about it once we get it. Let's start by simply solving. We have 3x over x minus 1 plus 6x minus 9 over x minus 1 equals 6. Well, right away I see that I have a common denominator on the left-hand side, so I'm going to combine my stuff. I have a 3x plus 6x minus 9. That becomes a 9x minus 9 over x minus 1 equals 6. And just like we were doing kind of in that first example, I can treat like that 6 like it's over 1. And this can become a 9x minus 9 equals 6 times x minus 1. Which if I keep going from there, I can keep the 9x minus 9 equals 6x minus 6. And then it's just a simple case of getting all of the x's together. So if I subtract 6x from both sides, I'm left with 3x on the left-hand side. And if I add 9 to both sides, I'm left with a positive 3 on the right-hand side. So I get that x equals 1. But now I need to start checking, are my solutions real solutions or are they extraneous solutions? So that means I have to go back up to the top and plug in a positive 1. So if I put a 1 in here, then we're left with a 3 over, and then we have a 1 minus 1, that's a 0, plus, plug in a 1, we have 6 minus 9, that's a negative 3 over 0 equals 6. Remember, whenever you have a 0 in the denominator, you cannot do that. That number does not exist. You cannot divide by 0. So that means if you ever end up with a number that gets your denominator to be 0, then that is an extraneous solution. So extraneous solution. It is your turn. See if you can figure this one out. If you end up with hopefully you ended up with letter D, or no solution. No solution. Let's take a look at our next example. Example 4. We have, on Saturdays, Lee helps her father install satellite TV systems. The jobs normally take Lee's father about 2.5 hours, but when Lee helps, the job only takes them 1.5 hours. If Lee were installing a satellite system by herself, how long would the job take? Alright, so this means if we want to know how long it would take Lee, we have to figure out how fast she actually works on her own. And the only way that we can do that is figure out the information using the time that Lee and her father works. If we look, when Lee's father works alone, how much of the job does he finish in 1 hour? If it takes him 2.5 hours to finish a job, if I split that up into an improper fraction, that becomes 5 halves. And how many of those parts are done in 1 hour? There'd be 2 of them. So 2/5 of a job in 1 hour is what Lee's father can finish. And then Lee, we are unsure of how much she can finish in 1 hour. So we're going to describe hers as 1/t, just because we don't know. But if we add Lee's speed plus her father's speed, we should get the equivalent of 1 job, right? So we can plug in our information. We have Lee set to be 1t, Lee's father to be 2/5, and we want it to equal 1 job. Well, if we multiply both Lee's time and her father's time by the amount of time it takes them to work together, which said 1.5 hours, I'm going to convert that to an improper fraction of 3 halves. And if I multiply this together, I end up with 3/2t for Lee, and then I end up with 3/5 for Lee's father, and that equals 1. If I want to keep solving from there, I need to have a common denominator. 1 common denominator, I could multiply my 2 denominators together and solve from there. But what I do to one side, I must do to the other. Or I just need to change my fraction, sorry. So in order to get a common denominator here, I have to multiply this fraction by 5. I have to multiply this fraction by 2t. So I'm left with 15/10t plus 6t/10t equals 1. Or I have 6t plus 15/10t equals 1. Treat this like a fraction, might make it easier. I know that I have 6t plus 15 equals 10t. Subtract 6t from both sides, I'm left with 15 equals 4t, or t equals 15/4, which is the same as 3 3/4 hours if Lee were to try and do the job on her own. Alright, driveways. Shawna earns extra money by shoveling driveways. If she works alone, she can finish a large driveway in 2.5 hours. If Vince helps her, they can get it done in 1.5 hours. If Vince were shoveling the driveway himself, how long would the job take him? So start by figuring out how much of the job Shawna can get done in 1 hour by herself. Figure out how fast Vince works, and then add them together, set them equal to one job, and see what you end up with. Hopefully you ended up with 3 3/4 hours. There may have been a few of you that realized the numbers were exactly the same and didn't actually do the problem, but make sure you know and understand the concept, alright? Our last example, we have a bus leaves the station and travels an average of 50 miles per hour towards the city. Another bus leaves the same station 20 minutes later and travels to the same city, traveling 60 miles per hour. How long will it take for the second bus to pass the first bus? So I started by getting this table. This is something that you would have to create, but it helps. So if I take the two different buses, so I'm told that the first bus travels d distance, we don't know how far it's going, but at a rate of 50 miles per hour, and it left t minutes ago. Okay. Bus number 2, or t hours ago. Bus number 2 travels d distance at 60 miles per hour with a time of t minus 1/3 because it left 20 minutes later, and 20 minutes is 1/3 of an hour. Some of you might be confused why the distance is the same, but we're looking to see how long it will take for the second bus to pass the first bus. That means that they are the same distance away from the bus station. Okay? So let's start by using the formula that you guys have used so often, I believe, in science. Distance equals rate times time. So if we do this, we have our first bus. Let's figure out how far that has gone. It goes 50 miles per hour, and it's been traveling for t hours. So we can represent that by 50t. And then our next bus is traveling at a rate of 60 miles per hour for t minus 1/3 amount of time. So this leaves me with 50t equals, and then if I distribute 60t minus 20, and if I subtract 60t from both sides, I'm left with negative 10t equals negative 20, or t equals a positive 2. So I know that t is 2 hours, but I'm not done yet, because if we look back at the table that I have, t represents the first bus, so 2 hours. So how long will it take the second bus to pass the first bus? So we have to plug that into our equation. So we say 2 minus 1/3, or 1 2/3 hours, which is the same as 1 hour 40 minutes. Okay? I want you to take some time, try to figure this one out. I recommend making a table similar to the last one. It just makes things easier in the long run. Hopefully you ended up with 3:27 p.m. If not, be sure to either ask myself or a friend. We'd be more than happy to help. I hope you guys have a great day.